Quantum internet isn't science fiction anymore. Today, I'll break down the world's first operational quantum internet backbone. Yes, the real engineering, not just a physics experiment. So what actually makes a quantum backbone? It's not just a fancy point-to-point link or some satellite trick. For a genuine backbone, three things need to work together at scale. Quantum repeaters to stretch range beyond 50 kilometers, trusted nodes to route between cities, and hybrid integration so the quantum layer runs on top of our existing classical internet. Previous projects like China's Mihyas satellite only managed secure point-to-point links. Impressive, but not a backbone. Now let's talk about the EU's Quantum Internet Alliance, or QIA. This is the first real deal, a multi-city continental-scale quantum backbone. Phase 1 goes live in 2025, connecting Amsterdam, Delft, The Hague, and Rotterdam, with Paris and Berlin joining by 2027. We're talking over €1 billion in funding and full integration into Europe's telecom grids. How does this backbone actually work? Let's compare it to the classical internet. In the classical world, signals travel as electrons or photons, carrying bits, 0 or 1. Security relies on math-based encryption, which honestly, quantum computers might break someday. Quantum internet, though, uses entangled photons to carry qubits, which can be 0, 1, or both at once. Security comes from quantum key distribution, rooted in the laws of physics, not just big prime numbers. But here's the catch. Photons lose their quantum state after about 50 kilometers in fiber optic cables. That's where quantum repeaters come in. Thanks to 2023 breakthroughs, these now use solid-state quantum memories, think rare earth-doped crystals like europium and yttrium orthosilicate, to store and transfer entangled photon states without collapsing them. Delft University's prototype achieved 87% fidelity at 10-kilometer hops, and that's a game-changer. For the first time, quantum signals can jump between cities without needing trusted nodes in every spot. That slashes the risk of hacking. Picture the real-world setup. Amsterdam's data center beams entangled photons to a repeater node in Delft, then out to banks in The Hague and the port of Rotterdam. The quantum layer rides on dedicated dark fiber, actual cables already in the ground. The classical layer handles normal data using quantum-generated keys for security. Special hybrid routers built by QIA Tech switch traffic between the two systems. So what's it for? Banks like ING and DNB are already testing it for unhackable transaction keys. Hospitals will share genomic data where no one, not even the provider, can decrypt your DNA. And by 2026, Dutch elections will use quantum-secured ballot transmission. But let's bust a few myths. The quantum backbone won't let you send messages faster than light. Einstein's still right. It won't replace your home Wi-Fi. In fact, it doesn't even send big files. It just creates unbreakable encryption keys. If anyone tries to intercept those keys, quantum physics guarantees the intrusion is detected. How does Europe stack up to the US and China? The EU's QIA network is the most advanced, real urban networks using quantum repeaters, not just satellites or trusted nodes that could be hacked. The US Department of Energy's QNext project is promising, but still relies on trusted nodes. China's Mihyas satellites can't do dense city networks and are weather dependent. So, when will you actually use this? In 2025, banks in Amsterdam and Delft will quietly secure transactions with quantum keys. By 2027, entire EU elections will run with quantum-secured voting. Come 2029, your phone's SIM card will likely have a QKD chip. Paying for coffee? That one-time quantum key makes card skimming physically impossible. This isn't sci-fi anymore. The physics is proven. The engineering works. Banks lose $4.2 billion a year to fraud. Quantum security pays for itself. In 2024, the EU even passed regulations mandating quantum security for all critical infrastructure by 2035. Want to track progress? Check the live node map at quantum-internet.eu, follow the US DOE tracker, or watch for new patents from QIA Tech and Toshiba. Bottom line, the quantum internet backbone is real. It's being installed under Dutch streets right now, and within 5 years, your phone will use quantum keys to keep your money, your vote, and your data as secure as physics allows. If you want a deep dive on the technology, quantum protocols, or even how to build your own demo, just ask.